let's talk about vector plot graphs. Now, we talked about in the previous video about factor loadings, and those were given in table 4.3 of the text. A vector plot graph can be constructed from the factor loadings of this table. The purpose of this video is to show you how to create a vector plot graph from factor loadings, and we'll actually apply this in the next video to the actual data in table 4.3. It is actually pretty simple when you do this. To create a vector plot graph from factor loadings, it's simply a matter of using the loadings of each variable on factor 1 and on factor 2 as coordinates for locating the endpoint to draw the vector for that variable within the two-factor space. Now let's say that a variable is correlated 0.60 with factor 1 and 0.80 with factor 2. We first create a circle for this factor pattern with a radius of 1. I'm not very good at drawing, but imagine we have a circle. Here is factor 1, and the y-axis is factor 2. And the radius is 1. So like I said before, the endpoint for this vector is plotted at a coordinate of 0.60 on factor 1 and 0.80 on factor 2. So we can go, I'm just going to guess 0.60, so we can say this right here is 0.60, and we can go up on factor 2, say this is 0.80. So if we go up and go here, we have a vector like that. Now it mentions this in chapters 2 and section 2.5, but since the correlation coefficients are cosines of the angle between the two variables, the angle between the variable and factor 1 is arc cosine 0.60, which equals 53.1. So that's here. This angle is 53.1 degrees. Similarly, the angle between the variable and factor 2 is arc cosine 0.8, which will give us, if you use a calculator, 36.9. So that's 36.9 degrees. You can see that there. Now we know that the square of a correlation coefficient, which is signified by capital R squared, also known as the coefficient of determination, it indicates the amount of variance accounted for. So factor 1 accounts for 0.60 squared, so that will be 0.36 or 36% of the variance, and factor 2 will account for 64% of the variance. 100% of the variance is therefore accounted for in the two-factor space, since this will equal 1 if you add them. And you can see in the vector plot graph that I did here, it will show that the factor structure for a variable that is completely accounted for by two factors. So factor analysis is obviously built upon the geometry of correlation coefficients, as it says in your text. So now that we know how to do factor plot graphs, we can apply this to real data that we got and that we talked about in the previous video from table 4.3, and we'll show that in the next video.